into Math 7. I'm Mrs. Campbell. Today we're going to be talking about the distributive property. Let's jump in. Let's review really quickly. Okay, so the distributive property of multiplication means that when faced with a term multiplying other terms inside parentheses, the outside term multiplies with each of the terms inside the parentheses. And here's an example. We have 28 times P plus 2F plus 5C. Put my glasses on here. And you can see the red lines show you how to distribute that 28 to the P, the 28 to the 2F, and the 28 to the 5C, which gives us 28P plus 28 times 2F plus 28 times 5C, which equals 28P plus 56F plus 140C. So the distributive property works when we have numbers inside the parentheses. And you can see this by looking at a simple problem and also considering the order of operations. So determine the value, here's an example, determine the value of 11 times 2 plus 6 using both the order of operations and the distributive property. So we're going to do it two different ways. Okay, there's the question here again for us so we can see it. First, we consider the problem with the order of operation. Remember PEMDAS. That dictates that we evaluate the amount inside the parentheses first. 2 plus 6 equals 8. Here's our 11. Here's our 11. 11 times 8 equals 88. Next, we're going to use the distributive property. We're going to multiply the 11 by each term inside the parentheses. So we're actually going to distribute the 11 to the 2, which gives us 11 times 2 plus 11 times 6 equals 22 plus 66. That also equals 88. So it can be done either way, order of operations or distributive property. Another example, determine the value of 11 times 2 minus 6 using both the order of operations and the distributive property. So first, we're going to consider the order of operations and evaluate the amount inside the parentheses first. So the 2 minus 6 gives us negative 4. Times that by 11, and we get negative 44. Now let's do it using the distributive property. We have 2 minus 6, okay? 11 times 2 minus 6. So let's distribute the 11 to the 2, and that gives us, try not to write on it, 11 times 2. We distribute the 11 to the 6, and we get 11 times negative 6. And then we solve, and we get 22 minus 66, and the answer again is negative 44. So remember that when you're applying the distributive property, you must take note of any negative signs. All right, another example, use the distributive property to determine the following. 11 times 2x plus 6, okay? All we have to do really is multiply each term by 11. So we do 11 times 2x, which gives us 22x, and then 11 times x gives us 66. And we add, so we have 22x plus 66. Here's another example. Use the distributive property to determine the following. 7 times 3x minus 5. Again, we just distribute. I want you to notice the negative sign on the second term. So that's going to change it. We're going to, first of all, have 7 times 3x, which gives us 22x. And then we have 7 times the negative 5. So now we'll have the negative 35. Because what we could say is plus a negative 35, but it's the same thing as minus 35. All right, another example, use the distributive property to determine the following. 2 over 7 times 3y squared minus 11. Again, we just don't let the fraction scare you. We're just going to distribute the 2 over 7 to both of these. So we have 2 times 3y squared minus 11, okay? And then we're going to do the 11. So we have 2 equals 2 over 7 times 3y squared plus 2 over 7 times negative 11. So we've just distributed the 2 over 7. And then when we solve, we get 6y squared over 7 minus 22 over 7. All right. Also, let's look at how we identify expressions that involve the distributive property. So, the distributive property often does appear in expressions, and many times it doesn't involve the parentheses. This might be new for some of you. It does not involve the parentheses as grouping symbols. So the following examples are going to involve using the distributive property with fractions. Let's take a look. Simplified 2x plus 8 over 4. Okay, so even though this expression is not written in a form that we usually associate with the distributive property where we have the parentheses, the fact that the numerator of fractions should be treated as if it were in parentheses makes this problem one that the distributive property can actually help us solve. So, did you know that 2x plus 8 over 4, so we got that denominator is 4, we can actually write that as 1 over 4 times 2x plus 8. So the denominator 4 can be changed into the fraction 1/4. Then we distribute the 1 over 4. 1 over 4, pretty cool, right? So all we do now is distribute 1 over 4 times 2x plus 1 over 4 times 8. All right. So we have, that gives us 2x plus 4 plus 8 over 4. Then we're going to simplify. We get 2x. Break down that 4 into 2 over 2. Break down the 8 into 4 over 2. Then you can see we just canceled these out. So we now have 2x over 4 plus 8 over 4. That equals 2x over 2 times 2 plus 4 plus 4 times 2 over 4. Then once we do those two cancellations, we cancel the 2's and the 4's, then our solution is x over 2 plus 2. All right, here's another one. 9y minus 2 over 3. That actually, same thing. We can take that denominator 3 and turn it into a fraction of 1 over 3, 1/3. Then we'll just have to distribute it. Okay, let's look at how we do that. So we're just going to distribute the 1/3 to the 9y and the 1/3 to the negative 2. So we get 9y over 3 minus 2 over 3 equals 3 times 3y, we just broke down the 9 over 3, minus 2 over 3. We cancel those 3's, and we get 9y minus 2 over 3 equals 3y minus 2 over 3. All right, let's quickly look at a real-world problem that uses the distributive property. The distributive property is one of the most common mathematical properties to be seen in everyday life. It's all around us. It crops up in businesses, in geometry. Anytime we have 2 or more groups of objects, the distributive property can be used to help us solve for an unknown. Let's look at this example. An octagonal gazebo is to be built as shown on the next slide. I'll show you a picture. So the building code requires 5-foot-long steel supports to be added along the base and 4-foot-long steel supports to be added to the roof line of the gazebo. What length of steel will be required to complete the project? And there's a picture for you. So each side will require 2 lengths, 1 of 5 and 4 feet respectively. So there's 8 sides, and so here's our equation. Steel required equals 8 times 4 plus 5 feet. Then we just use the distributive property to find the total amount of steel, which is 8 times 4 plus 8 times 5. I just distributed the 8, and we get 32 plus 40 feet. Adding those together, we get a total of 72 feet of steel is required for the project. All right, let's summarize what we've learned here. The distributive property is the multiplication of a number and the sum of 2 numbers. It's equal to the first number times the second number plus the first number times the third number. An example is 4 times 6 plus 3 in parentheses is the same thing once we distribute the 4 as 4 times 6 plus 4 times 3. when we're applying the distributive property, it's really important too that you make note of any negative signs. All right, everyone, that does it for this lesson. Thanks for joining us. We'll see you next time. Bye-bye.